In this problem, I want to find the dimensions of a open-top cylindrical container that will minimize the surface area. So we know the volume of the container. We want to minimize the surface area. So I'm going to start by writing the formula for the volume of a cylindrical container. And that is pi times r squared times h. So that's the volume. The surface area, it's an open top container, so there's a bottom to it, and the area of the bottom it's the area of a circle, so that's pi r squared. Plus, we need the area of the sides of the container. So, this is my container. Imagine that I cut along the height of the container, and let's imagine that the bottom is open. So now when I cut that and I open it up, what I get is a rectangle. And the height of the rectangle is the height of the cylinder. And the length across the top of the rectangle is the circumference of the circle. So that's 2 pi r. And since this is a rectangle, the area of it is going to be 2 pi r h. So that's how I figure out the surface area of my cylinder. Okay. Now, in the problem, they told us that the volume was 1,331 cubic centimeters. So that means that pi times r squared times h equals 1,331. And I can solve this for h. I could solve for either r or h, and mathematically it doesn't matter, but it's easier to divide both by pi r squared. And then we have h equals 1,331 divided by pi r squared. So I'm going to take this expression and replace the h in the surface area formula with that expression. So that means that the surface area is pi r squared plus 2 pi r times 1,331 over, what was it? Oh, pi r squared. Okay, I can cancel the pi. I can cancel this r with one of these r's. So now I have the surface area is pi r squared plus 2 times 1331, and that's 2662 over r. I want to, minimize the surface area. So I'm going to take the derivative of the surface area. And the derivative of pi r squared is 2 pi r. And the derivative of 2,662 over r If it makes it easier, just think of this part as being 2662 r to the negative 1. So this is going to be actually a negative 2662 r to the negative 2. Okay, so now I want to minimize this. I'm going to set that derivative equal to 0. So 2 pi r equals 2662 r squared. Oh, sorry, to the negative 2. Let's see. Let's multiply both sides by r squared. So now I have 2 pi r cubed equals 2662. And I'll divide both sides by 2 pi. And r cubed then equals 1331 over pi, and r is the cube root of that. So I put that into my calculator. All right, I just popped that into my calculator, and I got 7.51. So that's the radius. Now I can find the height by just popping that radius into the height formula. So this is going to be 1,331 divided by pi times the 751 squared. And again, I get 7.51. So that's how you solve that problem.